Good morning. Today we're going to go over geometry lesson 1.2 on measuring the first dimension, which is length. And you're going to be able to measure the length of one side of a triangle if you know the lengths of the other two sides by using the Pythagorean theorem. And this lesson supports IXL skill Q1, which is on the Pythagorean theorem. So what we're going to go through today is to make you better at recognizing how you can use triangles to find the side or the length of one of the sides, so long as you have the two other sides available to you. Now, you're going to say to yourself, well, what if we don't have a triangle? How do we find the length of a side? That's a good question. We start here, though, because this is historically where this subject was first really taken up. So take notes on this lesson, and as a header, put your name, your first and last name, date, period, and the lesson notes name and number at the top, and then upload those to me through this Synergy View by 11:59 p.m. next Saturday. Okay. All right. So, where does the Pythagorean theorem come from and why does it work? So this fellow here, this bust, is meant to represent a Greek by the name of Pythagoras. And Pythagoras came from an island, I believe it's in the Mediterranean, it could be in the Aegean, but it's called Samos. Samos. There's his name right there, and the island's name. And although the theorem appears to have been around 1,500 years, Pythagoras is the one who it's attributed to. Now, why is that? Well, I guess he was just the best promoter at the time in getting the word out to a lot of people. Remember, everything went by word of mouth in those days. So, nevertheless, this fellow was extremely talented, and he was very observant. All these gentlemen at that time, where did they learn their math from? It was from observation. They looked around, they saw things, they saw relationships between things, and they were able to predict what would happen next. So this is what happened here. Pythagoras, or one of his predecessors, observed that a right triangle could be divided up into three right triangles that are proportional to each other. Using this idea, he was able to create an equation where the sum of the squares of the two shortest sides of the original triangle equaled the square of the third, which is the longest side. This is called the Pythagorean theorem, which means just simply Pythagoras' rule. And so this is it. This is the formula. And again, if the two shortest sides have lengths of A and B, and the third longest side had a length of C, then A squared plus B squared equals C squared. And this is the Pythagorean formula. Okay? We're going to get into this more deeply, and we're going to talk about it. So don't worry if this is confusing to you at this point in time. We're going to draw some pictures, and we're going to talk about this. Okay? So wherever you encounter a problem where there is a right triangle, and you're given the measures of two of the sides, you can use the Pythagorean formula to solve for the third side. I mean, that's the basic thing that we're doing here. And that's what I was saying before with all the mathematical legalese, if you will, in the previous page. So you can also solve word problems. So that, you know, up here, could be part of a word problem, but a lot of problems are where they give you the obvious drawing of a triangle and they tell you solve for one of the sides. But sometimes you're given a word problem and it's not so apparent that you've got a triangle. So what you do is look at the facts of the problems. They will describe the shape that you should be able to recognize as a right triangle. And we're going to look at one of these actual problems so you can see how it works. Now, this is important. You've got to draw the triangle. Sketch it out. Make sure all the parts fit with the description in the problem. determine which side is longest. That's extremely important. And here you're going to just, how do you find that out? Just use your eyes, for God's sakes. Okay? This will be your C side. Remember we talked about the square of two of the sides, which are your A and your B sides, equals the square of the C side. So the other two sides will be, as I said, the A and the B sides. And you use the Pythagorean formula to solve the problem. And again, it's A squared plus B squared equals C squared. That's where A, B, and C are the three sides. All right? So if I were to look at a drawing of this, here I've sketched down here at the bottom a triangle. And it's a right triangle. How do I know it? Because I put a little box in the corner. And although this is kind of sloppy, this A side that I've identified as vertical, the B side is horizontal. Now, it doesn't really matter if you make your A side or your B side the horizontal or the vertical lines. We could switch those. But the C side always has to be the longest side. Well, how do you find that out? Well, when you draw out your triangle, using, again, the information they give you, you should be able to eyeball or determine the third side being the longest side, okay? And that's your hypotenuse, which is a Greek word. And at this point in time, I don't know exactly what it means in Greek, but basically it's the line across from the right angle there. So if I were to draw the red line, assuming my pen works, from that angle over here to this third side, that third side is indeed the hypotenuse. Okay, it's your C. Okay. All right. So let's look at how you would do that. So you solve the formula by undoing, and that's the reverse of PEMDAS. And you remember PEMDAS is the order of operations. That's old middle school. Here's PEMDAS. I've written it out. And you can see I've highlighted the first letters because that's what makes up the acronym PEMDAS. Parentheses, exponents, multiply, add, and subtract. But when you undo, you reverse PEMDAS. And the reverse is sometimes called SADMAP because that's just PEMDAS in reverse. See, because here's parentheses, exponents, multiply, divide, add, subtract. But we go the other way, of course. With SADMAP, we start out with subtract, add, divide, multiply, exponents, and parentheses. Now, why do we do that? Because we're undoing. So figure in the morning, when you're putting something on, you are buttoning things up, and you start with your underwear, and you move all the way to all your outer clothing. At the end of the day, when you go to bed, you undo everything. So you're doing the exact reverse. So that's the theory behind this. It's very simple, but it's how we solve for any given variable. So, maybe A is the unknown. So that means we want to isolate and solve for A. We'll get the values for B and C. Or maybe it's B that's the variable. Okay? Or, of course, it could be C. All right? We'll see. All right. Here is, let me see, did we get everything? Yes. So here is an example, very simple. This is something that you would see in IXL. So this is a typical IXL problem. One of the complaints people have of IXL problems is that you get something like this. What is the length of the hypotenuse? And you're given a picture. Well, okay, so what do you have to do? You have to look at the picture and determine what it is. Oh, it's a triangle. And what kind of a triangle is it? It's a right triangle, right? 90 degrees, a right triangle. That little box means it's a right triangle. So we know this is a right triangle. And I'm just going to use the shape for triangle, right? And we know that we have two sides here that we have the actual measurements for. It's the c side we don't know. Now, what's the rule? What is the c side always going to be? Well, if you remember, you can go back and look at the previous page, but the c side is the hypotenuse. And remember, how can you find the hypotenuse? There's really two ways. One is look for the longest side. Well, the 7 centimeter side, if you just eyeball this, it doesn't look nearly as long as the c side, right? Neither does the 8 centimeter one. So c's got to be the longest side. And it just so happens that c is across from the 90-degree angle, and that's always the case. So this is the hypotenuse. And it's always going to be your c, always. These you can reverse. So what do? So you're going to go ahead and set up your problem. So the problem is, so this is a right triangle. You can solve for the missing side with the Pythagorean theorem. Okay, so the Pythagorean theorem formula is a squared plus b squared equals c squared. All right, well, we know this is c, right? Well, we can just arbitrarily make either either the 7 centimeter side, the a, and the 8 centimeter side, the b, or we could switch that. But it doesn't matter. It's obvious to see that you could switch these because these are added together here. So I'm going to put in, since my a is 7, so let a equals 7 centimeters. Let b equal 8 centimeters. So I've got 7 and I got 8. Those are the two I'm putting in here. We're squaring both of these. So 7 squared plus 8 squared equals c squared. Now, you do not have to necessarily rely on your calculator or your memory. If you need to, you don't have to rely on your memory or your own arithmetic to figure out what 7 squared is. Well, 7 squared, as you know, though, is 7 times 7. So if you have to, get one of these, a calculator, right? Let me turn this light off. So, 7 times 7 is 49, or 7 squared is 49. I'm going to show it to you two ways. 7 times 7, I'm just multiplying, equals 49. Or I could do, I can use the setting here, 7, and then there's a caret. You see a button up here? Button up here that looks like a little arrow. We call it a caret. You press that, and it creates a little caret there, and then you put a 2 for squared, and then you click enter, and you get 49. So that's the other way of doing it. So you could do 7 cubed, and you know what that instantly is. But here, this is 49, so 49, and then what is 8 squared? Well, 8 times 8, if you use a calculator, you'll find it's 64. So I've got 49 plus 64, and that equals c squared. All right? So what is 49 plus 64? 9 and 4, that looks like 13. 6 and 4 is 10, and 1 is 11, so I think that's 113. Let me just see if I'm right. So 7, so that's 49. 49 plus 64, because I can even make mistakes. Yep, 113. So 113 equals c squared. Now, here's the thing. If you know your numbers, you might be saying to yourself, well, shoot. I don't know, 113, I don't think I can make a perfect square out of that? Well, how do we figure that out? We can do it in our head. We could say, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. Now, if you know your times tables, you can do this. 5 times 5 is 25. 6 times 6 is 36. 7 times 7, we already said, is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. So somewhere between 10 and 11 is what C is. Okay, so we want to find out what C is. So what we end up having to do is we end up having to take the square root of both sides, because that's what when we're multiplying two numbers together to find this is what it ultimately is. We're doing the opposite of the square root, which is to square numbers. Okay, so the opposite of squared numbers is to take the square root of both sides. So let's do it that way now. Okay, and so the square root of 113, I can do one of two things. I can come up with an approximate answer on my calculator. How would I do that? What I can do, if you look at the buttons down here, you will find, see this x squared button right here? Just above it, there's a kind of looks like a division sign that has a hook on it. That's a radical sign, and it's in blue. So that means I push this button up here, this blue button that says second, and then I push the x squared button, and I'll get the square root sign instead. So there it is, and then I type in, you notice there's a parentheses, 113. I have to close that parentheses. I just put the 113, which was what was in my problem, down here by my finger, and I'll click enter, and I get approximately 10.63. See that again, 10.63. So 10.63 is approximately what C is. Now, why do I have to find C? Well, remember, I'm looking for the length of this side, C. And it's not C squared, it's C. So you've got to, even though you start out with this formula, you've got to deal with this construct. So you're going to say, well, I don't know if I like that. Well, all right. So it's the reality of anything squared. We're going to have to do something with radicals. Okay, we have to take what we can get, and this is what Pythagoras gave us. Now, there's another way we can solve this. We can factor 113. We already know it's 49 times 49 plus 64. 49 we already know is 7 squared, right? And plus 64 is 8 squared. The problem is we don't have, when we multiply that all together, we don't have a perfect square, because 113 is not a perfect square when we multiply it and add it all together. So let's do this. Let's just go over here on the side. Oh, let me add this. So take square root of both sides. And this is our approximate answer by calculator. So if you want an exact answer, you actually have to leave this answer as some kind of a mixed radical. Just like you find that certain fractions are approximations. So like 1/3, I can write the fraction 1/3. That's easy to see, it's exact. But if you try to turn it into a decimal, which is what this is over here, that's an approximation. And 1/3, when you turn it into a decimal, is an approximation. It isn't exact. So we want to get the exact answer. So what we do is we just take and factor 113. So can I divide 113 by 2? No, because it ends in 3. I'll just show you on my calculator. 113 divided by 2 gives me a decimal answer. So that's not what I want. I know that 113 divided by 3 also gives me a decimal answer. Let's try 6 because we had, no, I'm sorry, 7. Let's try 7 because 7 was one of the factors we originally started with. But remember, those are added together. It's 7 squared and 8 squared, so it may not work. But let's try 7. So 113 divided by 7. Oop, you see it doesn't work. How about if we do 113 divided by 8? It doesn't work. You keep getting these estimates. So what's the most exact answer here? The square root of 113 does equal C. That's the exact answer. Okay? That's the exact answer. That's what you're left with. So I suspect, IXL will tell you, it'll say, it'll either give you the ability to do a decimal, or it'll give you the ability to do a radical. If it's a decimal, then you know you go this way. If it's a radical, you go this way. Okay? All right. Otherwise, you will get the answer wrong as far as Desmos is concerned. I'm sorry, not Desmos, IXL. If I said Desmos earlier, I meant IXL for this. Okay? We're talking IXL. How do we, this is a typical IXL problem. How do we solve it? All right. So here's the last one we're going to do. So here's a word problem. And again, it's an IXL style word problem. So you see 3 baseball players, and they're playing catch. Now, cue in. Always cue in on numbers. 3, magic number. So we got Adriana is directly south of Greg. Oh, okay. So we got 3 baseball players. Now 3 means, what shape does that suggest to you? Maybe a 3-sided figure, right? So probably a triangle. So Adriana is directly south of Greg and directly west of Troy. So let's sketch this, okay? So here's Adriana up here. Oh wait, let's not do it that way. Let's do it down here. Draw a diagram. Adriana, so here's, let me make a little compass rose. So here's north, here's south, here's west, here's east. We call this a compass rose. Why? Because they used to have a circle around it and they think of a rose, right? Okay, so she's south of Greg. So Greg is up at the top. Okay? And then she's directly south, so that's Adriana. And she says Adriana is directly south of Greg. Yeah, that's right. Okay. And directly west of Troy. So she's west of Troy, not the other way around. So you got to think about this. She is west of Troy. Well, if she's in the west, she's got to go to the east, right? So here's Troy. What does it form? Aha, triangle. Now they go on to say that Adriana and Troy are 6 meters apart. Well, let's see. Here's Adriana, here's Troy, 6 meters. And Troy and Greg are 10 meters apart. Troy and Greg are 10 meters apart. That's over here. Okay. Now, compass rose, you'll notice, is 2 lines that intersect, and north, south, east, and west are at 90-degree angles. This is something we just should know. So that means then, that these are right angles, right? And so this is a right angle. It's 90 degrees. So what kind of a triangle is this? It's a right triangle. Okay? So this is a right triangle. So we drew the diagram. And now we can instantly see, oh, here is, this is 6 meters. Oh, and this is 10 meters on this side. This side over here has got to be our unknown. Now, which one is the C? Well, which is the longest side? It's got to be GT, side G, set line segment GT, which is directly across from angle A, which is where the right angle is. So this is obviously C. And so we can say this is A if we want, and this is B. So B equals 6 meters, C equals 10 meters. All right? So A squared plus B squared equals C squared. Let C equal 10 meters. Let B equals 6 meters. What is C? I'm sorry, what is A? Equal to. Okay, that's what we're looking for. All right, so we know this is C, so this is going to be 10. And we said that this is going to be our B, so B is 6. And then we're going to square, and then this is our A squared. Okay. So now we've got to solve this equation. All right, so what are we going to solve for? Well, it's got to be the A. The A is the only variable on its own. So we got to get it by itself, which is undoing. Remember, we undo. So we want to isolate A by undoing, which means get it by itself using what? SAD map. Okay, that's what we're doing. So A squared stays A squared. So A squared. All right, now we have 6 squared here. So we want to get it by itself. So plus 6 squared equals 10 squared. So we're going to subtract, because we're going to do the opposite of adding. We've got to do the opposite when we're undoing. When you were putting it together, you were adding it to the A squared. Now you're going to take it away, so you're going to subtract it. So you subtract 6 squared on both sides. Okay, so this is going to go away. Now I could have and should have probably started out by simplifying, which is really, you know, combining like terms, which is PEMDAS. I should have squared the 10 and squared the 6 beforehand, but I can do that now. That's one nice thing about geometry. We can be a little more lax when it comes to, you know, how we do the order here. Oops, A squared then is going to equal, well, this is 100, 100, 10 squared is 100, and 6 squared, 100, and 6 squared is 36. So A squared equals 136, right? Okay, so we know that. So then the question becomes, oh, you know what? I just realized I did something wrong. I always have to check myself on these things here. Let me see here. Or maybe I did it right. Let me see. 6, 10. Okay, so Adriana is directly south of Greg. Greg. Oh, Greg and Troy are 10 meters apart. See the mistake I made? Greg and Troy. No, I did that right. Greg and Troy. So Adriana and Troy are 6 meters apart. Greg and Troy are 10 meters apart. I did it right. Okay. You always double check these things just to make sure. So I just went back up here and I looked and I said, okay, Adriana is directly south of Greg. There she is, south of Greg. And west of Troy, so Troy is east of her. Adriana and Troy are 6 meters apart. Troy and Greg are 10 meters apart. So we C is 10. And B in this case is 6. 6 times 6 is 36. And 10 times 10 is 100. Oh, I know what we did wrong. I knew there was something. We're subtracting, right? So let's get rid of this and let's just move this over here. So we have a squared equals, well, 10 squared we said is 100 minus 36. So what is 100 minus 36? Get your calculator out if it's easier for you. Sometimes I have to do this. See, it's easy to get carried away and do it wrong. Okay, what is that? Oh, it's 64. Okay, well, that kind of makes sense when you consider that we use the same numbers as before. So a squared equals 64. All right, what is a squared? So we have to take the square root of 64. And again, you could go do it backwards and say what times what equals 64. And you probably remember from your math what it is. Remember, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64. So obviously A equals 8 meters. Okay? And if you want to prove it to yourself again the other way, just go over here and you take the square root of 64. So I'm going to clear this. I'll go up here to my second button, click my, again, my little square root button, which is the x squared button. You see the parentheses and the square root sign. You put in 64, close the parentheses, hit enter, and you get 8, okay? Which is what we wanted. So there you are, ladies and gentlemen. That is it. You're taken care of, and we did it in good time, so I'm pleased to say you should be able to work on these. Now, where are we going from here? Well, hold on your hats, and we'll see how we can get away from having to do this with a triangle, but I think for a while we're going to hang with the triangle and just see other aspects of it, and then we'll go on to other ways of finding length here, that first dimension. Thank you very much. Have a good one. Bye-bye now.